do deep diving revision when we come to round 2. So our discussion today is ethanoic acid. Ethanoic acid. Trivial name, acetic acid. Acetic acid contains an ion. An acid will always have a minus ion and a H plus. So it will have an ion, and this is the negative ion, which is known as acetate. Acetate ion is always CH3COO minus. So what is ethanoic acid? CH3COOH means it is like CH3COO minus and H plus. This H plus is actually making it an acid. Okay? We study this acid as a part of carboxylic acid group. Carboxylic acid. What is a carboxylic acid? Someone with a dash COOH. So how does it look like? Something C double bond O OH. And who is pairing here? CH3 is pairing here. So that's how you get the formula CH3COOH. Right? And since we have got two carbon number 1 and carbon number 2, so we use the word eth and ethane. So anes E becomes oic acid. Clear so far? Since ethanoic acid is a carboxylic acid, so this acid is also a organic acid. And organic acids are what? Weak acids. All stories will become clear. So they will also perform the litmus test. What is litmus test? They will make blue litmus into red, but you can't expect very reddish color in this case because they are weak acids. It will be a little bit yellow pinkish type of red. Extreme red you will see only when you have strong acids, and strong acids are inorganic acid like sulfuric acid, hydrochloric acid. Have you understood this? Okay. Since this is an acid and we have studied about a reaction which is known as neutralization reaction. So do you see, one chapter's question can be merged with another chapter, neutralization. What is neutralization reaction? An acid reacts with a base to form a salt and water. So let's see this case also. Generally we always do HCl plus NaOH, but this time we will be using CH3COOH. Why are you using this acid? Because sir, the topic is about this acid only. So CH3COOH will now react with what beta? Sodium hydroxide. Okay. We also learned one more thing. Okay. Like in amphoteric salts, another thing. Out of here, whom do you see more powerful? The base is more powerful. So the child that will be born will carry the basic property. It will be a basic salt. Right. So how is the salt formed? The salt always picks up Na from this side and the negative of this side. Remember, NaCl, HCl Cl and NaOH Na. NaCl and water used to be formed. Now you will pick up. So you should know. Here we in organic acid salts, you use the cation first is always written later. The anion part is written first. See, if I write sodium chloride, what is sodium chloride? NaCl. I write the cation first, Na plus Cl minus. Whereas in organic salts, how will we write? We will always write the anion first, the cation later. Look at an inorganic acid, HCl, H plus Cl minus. How is it? H is later. Okay? So here, the product that will be formed is CH3 and thus write tuna. This is the acetate ion. This is the sodium ion. So this is a salt. So this salt will be known as sodium acetate. Like that, you can make sodium citrate, sodium malate, sodium lactase, so sodium acetate, and don't forget water. So this is also one reaction which you can use. So you can write ethanoic acid reacts with a base to form sodium salt, so with salt, which is base is sodium hydroxide, so the salt will be sodium acetate, CH3COONA. So if you look at this, the H has been liberated out, creating one more valency. If you want to see that in more broken manner, it's like this: CH3, C double bond O, O, and the H is gone, creating one more valency now. So H carries a positive charge and goes away. So this ion overall, this entire thing overall has a negative charge now. To neutralize that, a sodium has come here. So this is CH3COONA. Clear? No issues? Our next reaction we will see, though it may be in NCERT or not. If it is not there, we'll not study in second round. Reaction of this acid with, now you tell me, common sense. Acid, I will make it react with carbonates and hydrogen carbonates. Okay, we'll go very specific. Have you written this one? Can I change this slide, children? Okay. Oh, Vakul is doing a stylish camera. I mean, it only shows his scalp. Good hair oil. I appreciate. So, let's say we see what is the reaction of ethanoic acid versus carbonates and hydrogen carbonates. I will see whether you have developed that knack by now or not. Carbonates and hydrogen carbonates. What are carbonates? Carbonates are salts which will have CO3 2 minus. Got it? Carbonate ion. And hydrogen carbonates are HCO3 minus, also known as bicarbonate. Clear? If I satisfy this with 2 sodiums, then what does it become? Sodium carbonate. Sodium carbonate, what is the trivial name? Can anyone tell me? No looking back. Trivial name. Hey, so you are not loving it. Washing soda is Na2CO3.10H2O. This is soda ash. This is soda ash. Yes, in grade 8, if you see the, say this as washing soda, I'll give you full marks. But grade 10, I'll not give you. Washing soda is when Na2CO3 is surrounded with 10 molecules of water of crystallization. Na2CO3.10H2O. And here I will satisfy it with only a Na plus. This becomes sodium, hydrogen carbonate, also known as sodium bicarbonate, also known as baking soda. This मत भूलिए. If you land up with a cranky like me in an interview panel after 4 years of engineering or whatever, then I'm ruthless. I will never ask you high-end questions. I'll just ask you what do you do or not, and from there the questions will be created. What is baking soda? See, sometimes in YouTube you have some IAS mock interviews. So whoever has gone, he or she might be a doctor, engineer, scholar, graduate. And the people who interview, whatever, I was a history major, and then suddenly they'll ask a history question. I'm an electronics engineer, and then I did my UPSC. Okay, what is a resistor, and what is resistivity? I mean, of superconductors or resistivity of semiconductors with increase in temperature. What happened? Sir, I have forgotten. You can't answer that. You were an engineer, then you did your UPSC. See, when you go up in a higher role, you have to be a manager. You have to see that the maid comes on time, sweeps from the corner of the house. Okay, clear? So let's see the reaction now. So let's take Na2CO3. So we'll have CH3COOH. Acid is reacting with Na2CO3. Okay. Now let's see what all will happen. Now in this case, since you've got 2 Na, we'll take 2 molecules of CH3. So first thing is, obviously we will get tuna, CH3COO Na. How many of those you will get? 2 of those we will get. Got it? Then CH3COO gone. H is remaining. And here CO3. CO3 will make CO2. So you'll get CO2. Plus H2O. Do you see something here in this reaction? Now my question is like that Dronacharya to others. What do you see? Bird. But what did Arjun say? The eye of the bird. Do you see the eye here? That is where you are lacking in your love for the subject. This question can be posed as a, this test can be as a confirmatory test in a lab. Because this is something that you can test. Lime water turns carbon dioxide milky. Carbon dioxide turns lime water milky. So if you perform this test, how do you know you have ethanoic acid? So with ethanoic acid, I added sodium carbonate. And then I got a gas, bubbling out was seen. And when that gas was passed through lime water, it turned milky, which is a confirmatory test for this substance to be ethanoic acid. Only ethanoic acid will be able to liberate this. Why not? All acids react. Bring any other acid. This is from the acid family. CH3CO, ethanoic acid. Now, I don't know whether that is acid or not. I am performing an organic acid test. This is a confirmatory test. Acid reacts with metal carbonate to release. See, you know that, but you could not apply that knowledge to answer this. You know it. Very nicely you answered. But why did you not apply it? This is an acid. That's a confirmatory test for an acid. They will give you questions now based on this only. An acid, organic in nature, reacts with a metal carbonate, releases a gas, which has the capability to turn lime water milky. Complete the chemical reaction. Can you complete the reaction then with NaHCO3? See, in the chapter of acid, bases and salts, all schools must have done by now. This thing used to be either HCl or H2SO4. That's the only difference. Do you agree? You tell me, Shreya, your school has done this acid, bases and salt done. In this reaction, only this acid was changed. It was 2HCl and HCl. Rest is all same. So can you complete with NaHCO3? Go. At that time, we don't need to. CH3COOH reacts with NaHCO3. So you will form CH3COONA plus CO2 plus H2O. What is CH3COONA? Sodium acetate, or we can also write this as sodium ethanoate. CH3COONA. Trivial name would be sodium acetate, because acetic acid name itself is trivial. So this is trivial. IUPAC name will be sodium ethanoate. Sir, what is the difference between an ester and this? An ester is alkyl alkanoate. A salt is metal alkanoate. If this was an ester, it would have been methyl ethanoate. Ethyl ethanoate. If this is a salt, it will be magnesium ethanoate. Sodium ethanoate. Clear? लिख लीजिए. Write it. So what all reactions did you write so far? The first reaction you wrote was a neutralization reaction. Then the second you wrote is a reaction between carbonates and bicarbonates. Maybe your NCERT will not write these reactions because they feel you have already learnt it in acid, bases and salts. When you learned acids reacting with, camera is positioned correctly. Yeah. Acids are reacting with, what happened? The meeting, what is it written? The meeting is being, what? Something that's transcribed. Who is transcribing what? I don't know. My head was showing like the king Kanishka. Kanishka, do you know? Gupta period, have you studied or not? Pre-Gupta period, BC period, there used to be headless statues of Kanishka. Hey, what history have you studied? Kanishka statue is there. Kanishka statue used to be always headless. How do you know the name Kanishka? Any other? Anyone who can relate to the name of Kanishka? Anyone? No Googling. Kanishka is the infamous Air India jumbo jet which was flying from Canada and it was bombed mid-air and it went into the Atlantic with everyone dead. 1984. It's an Air India's aircraft. Kanishka. Kanishka was, bomb was planted in that aircraft and exploded mid-Atlantic. अगर कुछ पढ़ना है IAS वाइस तो all of you should buy one book called the Manorama Yearbook. Buy that book. Every year end it is published. Some current affairs will be changing. General knowledge remains the same. And when you are in a toilet seat, read the Manorama Yearbook. It's a good thing. You should know what happens. How does a bill become a law? End of the day, you will not study these. You should know the civics also. If a person is arrested, what are the rules? What are your rights? Do you know them? कुछ नहीं पता. So we don't know. चलो हो गया ये. Okay, next reaction. Our next reaction is the characteristic reaction which is known as esterification. Esterification. Esterification we see as what? We will see an acid. Esterification. So we will see the acid. Obviously this acid has to be a carboxylic acid. Carboxylic acid will react with an alcohol. Higher classes you will see this is a primary alcohol, and since you have to suck out water, so a concentrated sulfuric acid must be present. Concentrated sulfuric acid sucks out water, है ना? अब देख लो पुराना चिट्ठा, मजेदार. एटलीस्ट देखा ना, मजा आया कम से कम. तो क्या बनेगा? Ester. What are esters? Fruity smelling compound. It will be a R C double bond O O R dash. This is an ester. An acid is always a R C double bond O OH. See, when you go home and you study, ना देखो आपसे ये सब बनता है कि नहीं? Like the way I am writing, does it come naturally to you? You can also write Arcu. Arcu is also an acid, but Arcu I have broken here in more structured manner. Alcohol is always ROH, rho. You'll form acid and you'll be giving out what? Water. So rather than writing the alcohol this way, we will swap the alcohol and we'll write the alcohol in this manner. OHR. This is also alcohol. Clear? And then what will happen? Sir, this much portion will go out. This is water. And for your simplicity, you take this as R-OH. So you actually form RCOOR. Okay? Lick. Can you write it with the mechanism mode on your own, or you want my help? So let's write it. Ethanoic acid we are learning, which is CH3, C double bond O, O, H. I have deliberately written it like this. OH. और थोड़ा खोल के लिखा. ठीक है? It will react with, say, ethanol. What is ethanol? OH, C2, H5. This is ethanol, C2H5OH. Deliberately, I have somersaulted it, twist kar diya hai. Right? So, what do I expect? I would expect that this much portion will get out. Water. Hey Shreya, did you get that fruity smell in your experiment? She did some experiment also. Fruity smell?
A little bit.
A little bit, because you are using, you don't exactly have, vinegar is not 100% acetic acid, but if you have 100% acetic acid and 100% alcohol, then you mix it. You use what? Dettol. So Dettol is mild percentage of alcohol. If you use spirit, which is available with before giving that injection, the one that they give, that one will make you smell like that. Shataks. Okay, so we will be forming now CH3, C double bond O, O, C2, H5. And we will also have water. Don't miss out the sponge darling, who is concentrated, H2SO4. And the name will be alkyl. Alkyl is the one who is associated with the oxygen side. So with the oxygen side, I have got ethyl associated with it. And then on this side, how many carbon atom? 2 carbon atom. So ethanoate. So this will be ethyl ethanoate. And this is a ester. Esters can be again used for making the alcohol back. You take this ester and you heat it with sodium hydroxide. Though in NCERT they will not have it. Just take it. Take this one and heat it with sodium hydroxide. What will you get? CH3COO, COO, and sodium hydroxide is NaOH. That Na will come and sit here. It will form what? Sodium ethanoate. And the ethanol will be separated out. So in 11, when you see methods of making alcohol, you will study this also by hydrolysis of ester. Lakshmi Singh has that reaction in grade 10 also. So if you add NaOH with it, Na will come and sit here. It will form sodium acetate. So what is remaining? C2H5 from here and OH from Na. So it will form. If you are interested, CH3, C double bond O, C2H5, react this with NaOH. Got it? The C2H5 will be kicked out. So C2H5 kicked out. That means on this side, what will I have? CH3, C double bond O. The Na will come and sit here. So this is what? Sodium acetate, CH3 tuna. This is nothing but CH3, C double bond O, Na. And C2H5, so when Na went, OH was remaining, that OH comes here. So you get your ethanol back. Acha. In both these sections, I will dive into those in the revision part. Uses. People jump those, but those are the ones which will cost you marks. All 1 mark question comes from uses. In earlier days, straightforward question used to come, mention 2 uses of ethanoic acid. If you know nothing, you can at least write used in pharmaceutical industries, chemical industries, fertilizer industries and all, common questions. But be very careful, read the uses. Ethanoic acid is used for making acetic acid. Ethanoic acid is used for making cellulose acetate. An artificial fiber is there. We will see that, cellulose acetate. Ethanoic acid is used for making acetone. Acetone is a very common ingredient in any of these nail polish removers. Okay, perfumes. You know perfume, right? Perfume has got a base which is a volatile base. And then the main smelling thing. The smelling thing is mixed in the volatile base so that when you press it, it will take that odor substance along with it in the what you call the volatile base. The volatile base is acetone. Anything which you take in your hand and you feel very thanda. Have you ever held nail polish remover? Have you taken? It's very cool. So it has got acetone in it. Too much of acetone will make a white color impression on your finger. So to make acetone, acetone is what product? Can anyone tell me? Acetone. Which class of family? Ketones. Yes, it's a ketone. So ketones are manufactured using ethanoic acid. So this is all about ethanoic acid. Ethanoic acid is used in acetic acid. Ethanoic acid is used in cellulose acetate. Ethanoic acid is used for making acetone. Ethanoic acid is a common for pharmaceuticals, very much important. So uses of ethanol, uses of ethanoic acid. Because nobody will ask you a question directly. It will be punched in something. An organic acid used in the formation of acetone. Which is that? Remember, you know only one organic acid in this syllabus, that is ethanoic acid. And there is mention of one more organic acid. What is it? Methanoic acid as ant bite. When ants bite you, It's methanoic acid. What is the formula of methanoic acid? Aku, HCOH. Okay. Done. So we now come to the last part of the chapter, which is soaps and detergent. During Corona, this was removed. Again, it was brought in, but in a very small manner. Soaps and detergents. Detergent. Soaps and detergent. The basic. First, understand the basic. Children, because of your generation, the earth is suffering from two things, which is known as what? Soft water and hard water. Soft water is now no more to be seen. All the water that is coming in our house is hard water. So in this hard water, the tap water that you are getting, if you dip your TDS meter, what is TDS? Total dissolved solids. So you will see salts are there, and these salts are in the form of MgCO3, CaCO3. These are all hard water. If you drink it, let's first say if you drink it, what happens? If you drink it, there will be no taste. It will be carcinogenic for you. And in Hyderabad, we are in more problem because if you are in areas like Patancheru and all, there you even have arsenic deposits. A lot of pharmaceutical belt is out there. Wherever there is a pharmaceutical belt, that water bed is very bad. Once arsenic comes, means it is cancerous. You should ask a question: why is so much of cancer happening? Why is so much of cancer happening? So if you see, like last year when I was admitted and I had that kidney stone, so doctor was explaining me, if you see the geography of India, UP, Bihar people complains more about gallstone, whereas Andhra, Bengal, Orissa, you will have more of kidney stones. You know the gallstone, and एक आएगा urinary tract में, एक आएगा excretory tract में. So these are all because we are gifted with so many things. So when you use an RO will actually eliminate these, make it soft water, and then add some additional salts, without which it is not good. Absolute TDS 0 water you should not drink. Your TDS should be around 25-30, otherwise that water is of no use to you. Even when you drink it, you will just puke it because you will not find any taste in that water. So good ROs means your TDS should be 50, 55, 56 TDS. But that TDS, total dissolved solids or total dissolved salt, should be salts which are good. So we have a problem of soft water and hard water. Now, you all have not seen soaps. In our days, we used to have something called washing soap. Washing soap. And a very common brand was Tata OK. It used to be like a flesh color, round ball like this. Have you used Mysore sandal soap? Mysore sandal soap, have you seen the color? Same color used to be this soap. And one more brand was available. The name was Sunlight. So when we used to go to hostel and all, they used to give us one Tata OK, and this used to be like washing soap. Take care, rub it, chop, 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 keep on cleaning it. So Tata OK and Sunlight, when they were soaps, they work only on soft water, and they will create lather, you know, lather, foam. But now you don't have soft water in this environment. So slowly this product is also abolished. This is no more there. Who will buy? If you buy, you will curse the product saying that isse to kuch saaf hi nahi hota hai. So now what you have is something which is known as the Rin or the Ariel. I'm saying the cheap options, detergent cake. Name, use a word. Rin detergent cake. It's not a soap. It's a detergent cake. And they have been made solely to address this environment. So what are you washing your clothes with? Surf Excel detergent, Ariel detergent, or your Henko detergent, whatever you're using. And if you think you're promoting on some Amazon brands, Presto, then also detergent. All are detergents. Detergents will be working on hard water, right? But the bad part of detergent is not biodegradable. That means when you wash soap cleansed clothes besides the river or natural water base, it is biodegradable. It does not cause any harm. Whereas this one is harmful. When you let the water go into the water body, it is not biodegradable. I hope you know what is biodegradable. It does not dissolve into the biocomponents. So the same animal will be drinking this water, the same fish, and then Ishita, a Bengali girl, will eat that fish, and then she will complain of stomach pain. So ultimately, where that pain has come from? The pain has all come from this. Is this clear now? So let's understand first of all, what is a soap? Grade 8 and all definitions are simple. Soaps are sodium salts of high fatty acids. Acha. Sodium salt of an acid. Sodium salt of an acid, 10 minutes back we had discussed sodium acetate. It is a sodium salt of an acid. But here we have got some adjectives, high fatty acids. So let's see sodium acetate first. Sodium acetate is CH3COONA. This is not high. How many carbon atoms? 2 carbon atoms. So when we actually go for soaps, ये CH3 से नहीं बनेगा. It has to be a very long chain. NCERT doesn't discuss about it, but we can know. Chains are something like, and chains are very easy to create. What is this? Alkane CnH2n plus 2 minus 1. So this is CnH2n plus 1. Have you agreed? So we have chains with 15. So 15 twos are how much? 30. 30 plus 1? 31. COONA. Or C17 H35 COONA. These are soaps, sodium salts of high fatty acids. And when this particular number goes on increasing, organic acids are no more liquid in nature. They are all becoming solid. Boric acid, the powder with which we play carom, salicylic acid, which you put as cream, all are solids. Okay? So this is known as sodium. Okay, and this is also known as sodium. Trivial names, huh? This is 15. This is 17. Between S and P, which comes first? Which letter comes first? P comes first. P, the smaller one. So this is known as sodium palmitate. This is known as sodium stearate. If you want to write, you can write, just for your knowledge. How to remember? 15 is the smaller number. P comes first. That's how I remember. So sodium palmitate, sodium stearate. These are known as soaps. At your level, you should know a soap is a sodium salt of a high fatty acid, which only will work in soft water. Means in soft water, it will create lather so that it can take out your dirt. Our important thing is to understand how does it take out the dirt. So it will take out the dirt and it will wash away. But now all apartments we are having what? Hard water. So if you take a soiled cloth and you try to clean it with soap, it will not clean. Got it? So let's see what happens in soap. Ready? Shall we? Okay. So a soap molecule. Soap is a very interesting thing. We study what is known as a soap molecule. A soap molecule is typically represented like this. Tadpole-like structure. What structure? Tadpole-like structure. Out of which one side will be hydrophobic. Hydrophobic. They used to say in our childhood, if dogs bite you, you show hydrophobia. You know hydrophobia? The fear of water. Hydrophobia. Hydrophobia. So hydrophobic means you will not be having an affinity for water. Right? So this is actually the hydrocarbon part. Hydrocarbon part. Means this is my C15. Usually, not necessary. I'm just not necessary for you. First, for your interest, I'm saying this is the C15H31 part. Do you get it? And then the head. The head is the dash COO Na plus part. This is hydrophilic. So first understand, a soap molecule is a tadpole-like structure whose head is the sodium ion part. And this is hydrophilic. And the other side is the hydrocarbon part, which is hydrophobic. So this is hydrocarbon and this is the sodium part. Sodium attached with the acetate. Okay? Understood? Now let's also see one more thing. Likes dissolve in likes. Remember this. If you are a crook and you go to a new school, you'll mix with the crooks only out there. Likes dissolve in likes. So what does this mean? This means that we usually have two type of solvents, polar, non-polar. So if you look at the collar of your shirt, that particular dirt we always call as grease or dirt. Have you understood? Grease or dirt. And grease or dirt, beta, is something which is oily. Do you agree or not? It is oily. All of you know Prill. Have you Prill? You must Prill liquid detergent. You have made an omelette, and now you want to clean your frying pan. Your frying pan is oily, right? You can take some oil and put on somebody's face. Now, how do you clean it? You will put Prill on that, and then you gently scrub it. What are you actually doing? Okay, there is grease. That grease comes out of the oil pan. So if I directly take the oil pan in water, what will happen? Water will splash and bubble, droplets will be there. That means there has to be someone who actually mixes with the grease, and later on gets out with the water. But my soap is very stylish. This part is hydrophobic. It doesn't like water, but it is hydrocarbon. Means it is oily. All oils are hydrocarbon. As I told you, like dissolves like. The hydrocarbon part will attach with this grease. Got it? And then it will stick on all the grease with it. That's what when you do that Scotch Brite action. So you are making all the hydrocarbon parts get attached to what? Those particular grease. Right? So you have arrested the grease. Now they have to come out. These don't separate. These are very stylish. They will go as a decoy and they will say, our tail commandos will attack the grease. When the commandos said all grease attached, then this part says, I love water. Now it will attach with water and pull out all the grease and take it away. Is the logic understood? So this is hydrophilic. We'll see that diagram also. So grease is, or dirt, it is oily. So this oily will find an affinity. It will stick. It will stick to the hydrocarbon part. And the hydrocarbon part is hydrophobic. Is hydrophobic. It has nothing to do with water. It will just wait. It's like a joint operation, commando operation, where we have army commandos and the helicopter guy waiting up. Uri. Once everything is done, the helicopter will pull up all the commandos. So this is the helicopter guy, and these are the assault commandos. So they will attack with all the grease, all grease stuck, and then comes our helicopter. Roger 2 Alpha come in. So Roger 2 Alpha comes in, and this part is the sodium end part, and he is hydrophilic, and he will attach with water, and he will just pull it out in one go. Therefore, when you give your saris or your blazers or your coat and other things, what do you say? Bhaiya, dry clean karna, dry clean. Dry clean is a common man's language. Actually, it is petrol wash. What is the wash? Petrol wash. If they wash and give you the same day and you smell the collar of your blazer or your business suit, you will smell petrol. Because the business suit has got what in it? The business suit has got grease. Whenever we sweat, we become a little bit oily. Imagine, now I'm also sweating right now. Okay, then you will see some patch of sweaty or shiny part. No matter how much I wash it with water, it will not go away. You have to use soap. We are saying soap, but there will be some bathing soap mein ho jata hai, but they also have detergent properties. Otherwise, you are also bathing with the same water itself. So that will cleanse it out. Is this logic understood? A soap molecule is like a tadpole, and the tadpole's tail is the hydrocarbon part, which is hydrophobic. Since it is hydrocarbon, likes dissolve likes, shaitan ke sath mix hota hai. So he will go and attack the oil or the grease, and then he will cleanse them. By that time, he will call his super helicopter, who is the hydrophobic part, come, and they will attach out. Now let's see how we actually clean clothes. The first thing that we do is that we will dip our clothes in detergent solutions. These are soaps, not detergent. Okay, the action is same. You will dip it in a soap solution. After that, what would you do? You will do a little bit of 1, 2, rub it up like that. So you are trying to mix all the hydrocarbon parts with the dirt. Then the process is called rinsing. When a lot of water will be thrown and the washing machine goes on the rinse cycle, And at that time, this fellow is doing its work. He's pulling out everyone, properly rinsed. And then you spin and make it dry. आइए अब इस action को देखते हैं. So whenever there is a piece of dirt, say this is the piece of dirt. This is dirt. This is dirt. How do I write it? Grease. Grease. This is dirt. So on him, the attack will happen. Sir, so many resistances you are making. Have you understood now? So these are all the hydrocarbon end, and these are hydrophobic but greasophilic, and this is the sodium end. This is hydrophilic. This structure is called a soap micelle. Michelle, like girlfriend type. Soap micelle. It's called a soap micelle. Right? A soap micelle is a formation where many soap molecules attack grease. Now the attack is done. Now you'll call the helicopter and you'll do what? Thawing, water thawing, and rinse. You'll do a lot of rinsing. So when you rinse, the grease part goes away. This is the mechanism. And how to distinguish between soaps and detergents. So NCERT does not cover detergents in so much deep thing. If you want to know, like soaps were sodium salts of high fatty acids, detergents are sodium salts of benzene sulfonic acid. That name is not mentioned. Benzene sulfonic acid. Benzene is organic compound, that circle. So benzene sulfonic acid means it will look like this. Benzene, this is benzene, and here one hydrogen will be taken out. This is called an aromatic acid. This will have a smell. All detergents have smell. This is benzene sulfonic acid. Soaps are sodium salts of high fatty acids. Detergents are sodium salts of benzene sulfonic acids. Okay. Soaps will work only in soft water. And whereas if you use what you call hard water, which you have to use because your house has got hard water, but many people will say, no, in our tower we have fixed a softener. So no matter whatever softener you use, soaps do not work. If you use soap on hard water, then your entire clothes will come out with, have you seen sometimes you have washed a black trouser or a black jeans with what a white patches, it will come out. That word is known as scum. This happens when lather formation will not take place. That is typically happening because your detergent quality is not good and your washing machine needs a cleansing cycle. Typically, this will happen when you go for, our exams are over now, we went for vacation for 1 month. So in 1 month, what happened? You were using hard water, the entire silt formation takes place in your washing machine. So when you come back, what you should do? When you come back, you should not start your washing machine straight away. Do some dry runs, 2 runs with bleaching powder. Add some bleaching powder and give a dry run to the washing machine. The entire silt will come out and this formation will not be seen. So generally we come back from, oh, our suitcases have to be emptied and you put everything on washing machine after 1 month. You're understanding, right? It was hard water. Acha, how many of you have witnessed that after 7 days when you come back to your home, have you gone and seen your sink? Your sink will have white stains on it. Every day it's not there because every day it is getting washed out. Like my house, this flat, we don't cook here. If you go into the sink and see, then there will be some white stains. That is all this silt. And these silts will be there, which will form scum and they will go all on your fabric. So the first thing, when you come from a holiday, take some bleaching powder and put it on your, what do you call, or they will also have Kiwi Dranex type of things, or they have washing machine cleansing powder. That's nothing but bleaching powder, and give 2 cycles. Then start using it. Everything has got a little bit of science in it. Sodium hydroxide is not a detergent. Sodium hydroxide has got grease cleansing, grease attack Any oily thing it can clean. Sodium hydroxide is known as caustic soda that we use for cleaning baffles of chimney. That does not mean, but, if you ask me and you want to do my experiments, as I told you, towels become the best white when you wash them with toilet harpic. Yeah, that has sodium hydroxide. Take that, I do that. A toilet harpic does not mean I'm putting toilet water into my washing machine. I am taking the red harpic. I just open my detergent cabinet of my washing machine, and I pour that colorless thing gone, and I put my washing machine into heat cycle, and I give my white color shirt, everything white, white towel, white handkerchief, and white socks. Make sure the socks should not have any black band or red band, otherwise the white shirt will come out with Jaipuri print dupatta. Okay, so like I used to wear a lot of whites when I used to go to office. So in order for, otherwise your whites will not be that white in this water of Hyderabad. So you just put them and let it wash. So, and use a little bit of fabric softener. So the fabric will come and the towels will come just like Hayat Sheraton towels. They will be fluffy. I have some pictures. I'll share them with you on Teams. And they will come crystal clear. Cleanse with what? Toilet harpic. No, it likes dissolve like. So sodium hydroxide has a cleansing property for oil. All these dirts, the dirt that is there in your fabric are not that oily. They are oily to some extent, not that oily. But when you want to clean absolutely oily things, like for example, I'll tell you, common sense. Okay, see how chemistry should be put into practice. Recently, my daughter was learning driving on my car. So my car had that LL stickers on both sides. Now this L sticker remained on my car for 2 or 3 months. Now driving test done, license obtained. Now I need to remove the L sticker. So one morning, I was actually there when one girl saw me that I'm removing the sticker. Immediately she took the bag from her mother and she wore the school bag. Do you understand what I'm saying? My car is right at the podium. So I was removing the sticker. Time was around 7:15, school going time. One of my students noticed me that I am there. Mother was carrying the bag. Immediately she took out the bag and she wore it. And her mother is laughing like anything, saying that she has noticed you. So now I have removed that sticker. Now when I remove that sticker, that place will have all sticker gums. Have you seen? Now if you use water to clean it, in your whole life it will not be cleaned. Now what do? I did not bring any sort of what you call detergent or something from my house. And if you use Scotch Brite on that, it will put marks on the glass. But since we go so much of outstation travel, we always keep hand sanitizers in our car. The Dettol. So take some sanitizer. Sanitizer has got nail polish remover, organic compound, like dissolves like, and just do little bit like this. Oh my God. What happened? Yeah, little bit in this manner we did. Slight. Yeah, slight touch. Yeah, slight touch. And let that sanitizer little bit mix with that. Take one small cloth and just wipe it. It went off. Where did it go? It is now on that cloth as a dirt. Don't take that cloth and start cleaning the car. Otherwise, that will again get stuck on the car. What the idea? And it's removed every dirt absolutely spot free without any sort of hard work. Use chemistry to your practice. And that too, that sanitizer was what? That was an expired sanitizer which was given to me when I was admitted in hospital. The 3M bottle, you get it, right? Very liquidation nature. फेंकने का क्या है? कभी ना कभी काम में आएगा ना. Just put it, cleaned it, done. In fact, when they discharge you from the hospital, that's also I saw from the nurse. They had put one tape on my hand, which was called the dino tape. Dino tapes are like crepe bandages, and they will be very sticky, very, very sticky. So at the time of discharge, even if you remove a little bit, it doesn't come out. And if you have a little bit hairy, it will pain you more. I saw that nurse. She just came and put that liquid, very, very dilute liquid on my hand and said, 2 minutes, you sit, sir. After 2 minutes, it just came out. That is also a technique. So whenever you put any stickers on any place, first clean with a solvent. then all dirt will be gone, and then adhesive thing will come up. This concludes our chapter on carbon and its compounds. What is the time? Okay. So the way we study this chapter is, we first got to know about carbon, properties of carbon. A quick revision. What all did we study? We studied about carbon, properties of carbon, allotropes, catenation, okay, then tetravalency, okay, and then what is different from silicon? Silicon structures are not stable. Then we studied about graphite and diamond. Why does graphite conduct? Why diamond doesn't conduct? Graphite has got one free electron and it forms some sort of pi bond, hexagonal structure. Graphite is a very good lubricant because layers slide over one another. That was the story end. Then we came to hydrocarbons. Hydrocarbons main source. In 10 minutes, we'll do a fast revision. Main source is what? Always crude oil. Crude oil formation takes place by dead marine plants or animals. Then what did we learn about hydrocarbons? Hydrocarbons can be classified into saturated and unsaturated. Saturated hydrocarbon. Hydrocarbon means only hydrogen and carbon. And saturated hydrocarbon has got a single bond between carbon-carbons. Unsaturated can have double and triple. The unsaturated are further classified into alkene and alkyne. Alkane, alkene, alkyne. CnH2n plus 2. One hydrogen gone, CnH2n plus 2. It's become minus 2. Then CnH2n. Okay. After that, once we studied this, we studied about how normal hydrocarbons, the straight chain hydrocarbons look like. They can be branched, they can be straight, or they can also be in cyclic manner, like cyclopropane, that is also a hydrocarbon, cyclopropane, cyclohexane, these are also hydrocarbon. Then we took a dip at how to name it. So to name it, we see the longest chain and we see the nodes. The nodes should form the smallest number, and while you name them, alphabetical order also should be given preference. Nobody will ask you to name, but we understood what is 2-methyl and all. After knowing this, we got to know something about homologous series. Homologous series is a class of compounds which can be represented by the same generic formula, and two homologues differ by a CH2 group and by a mass of 14 AMU. They will show similar physical and chemical properties. Alkanes are a homologues, alkenes are a homologous series, alkynes are a homologous series. After we studied this, then we went into functional group. Because functional groups are atoms or a group of atoms which actually control the reactivity of that entire organic compound. Now we will no more call it a hydrocarbon. Okay. So the first is the halo group. Halo group is called the halogen family X. X can be chlorine, bromine, iodine. Then we saw the alcohol group. Then we saw carboxylic acid group. So for that we first saw carbonyl group. Carbonyl can give an aldehyde, can give an alcohol ketone, can give a carboxylic acid. Also a class called ester. We especially saw also what are amines and amide, though not required. Okay. Then after this, we saw how namings and all are done. Methanol, methanoic acid, then methanone. So, okay, methanone can never be formed. Ethanone can be formed. Right. Then we saw characteristic reactions. The first reaction was combustion. Combustion is shown by alkanes and alkenes and alkynes, but the difference is alkanes will burn with blue flame, alkenes and alkynes will burn with a sooty flame in ambient oxygen. If you supply more oxygen, then they will have complete combustion and give you a lot of heat. Gas welding is an example of that, also known as oxyacetylene welding. Then we saw another reaction, characteristic reaction of combustion is also seen by alcohols. Both are used as fuels. So a fuel with oxygen will give you carbon dioxide plus water vapor plus energy. Then we saw substitution reaction, characteristic reactions of alkanes like chlorination, chlorine reacting in the form of sunlight. So it forms chloromethane, dichloromethane, trichloromethane known as chloroform and carbon tetrachloride. Ye ho gaya. Then the next day we saw addition reaction. Addition reaction is studied under two heads. One is bromine water test, not in syllabus, but we can study that also. Dibromoethane, bromine water will lose its color, or hydrogenation, which is also an addition where hydrogens are added to alkenes to convert them to alkane. Commercially, they are used for making vanaspati out of vegetable oils. And that test reaction is done in the presence of nickel, platinum or palladium at 200 degrees Celsius. ये देख लिया था, addition reaction हो गया. उसके बाद oxidation. In oxidation, we were using nascent oxygen, 2 atomic oxygen. And the reaction was happening in the presence of alkaline KMnO4 or acidic K2Cr2O7, right? So when you acidify, then what happens? If an acid is formed out of a Oxygen is coming. You were earlier what? You were earlier OH. One more oxygen came, so you became an acid. Then we saw esterification reaction. Then reaction with metallic sodium, sodium ethoxide, right? Then hydrolysis, water was taken out. Then it became acids, became alcohol, became alkene. Ethene बन गया था, याद करना है आपको. Then esterification and then ethanoic acid. So. Next time when we go into this, so I'll try to get a summary notes also for all this. Next time what I'll do now, since these three are done, we'll then dive into metals and non-metals slowly. Once we are done, then we will do NCRTs, and because we have to capture some periods of chemistry into mathematics also.